water treatment, water management. My company, or our company, Watertech, works on the industrial side. We work every day of our lives with people who use lots of water for making stuff, for processing things, for doing whatever that we as consumers use in our everyday lives. And so our job is to help these guys reduce, reuse, recycle, conserve water, minimize environmental impact, and at the end of the day, help them be as efficient as possible as it relates to sustainable impact and how they run their process. So we have lots of smart systems that we put in the field to help replace people that either aren't there anymore because of attrition or a lack of knowledge that's coming into the field. And so there's a big knowledge gap. So with these smart systems, we get lots of data, but the challenge is that it's not in a format that's user-friendly and really easy for the end user to get a hold of, and at the end of the day really make it meaningful to them so that they can start to run their facilities better, reduce environmental impact, and again help do lots of positive things for their facilities. So our challenge was, how do we put together a dashboard or some way to help our users and help industry utilize this tremendous amount of data that's being processed every day and put it into some user-friendly format for them that they can easily then begin to use and make decisions on what's best for the environment as it relates to their operation, and hopefully also in addition to what's best for their bottom line to create jobs, keep businesses here, and move forward. So without further ado, gentlemen.
Thank you. That was a great introduction. And pretty much took care of most of what I was going to say.
Oh, sorry, Bob.
That's fine though. So what we ended up doing was, well, we picked this project partly because the data set was so rich, and it was kind of appealing to have this large set of data that we could just sink our teeth into and play with visualization. So the solution that we came up with, we started off by working with the Watertech guys to figure out what the data looked like and how it was all structured. So they have a hierarchy to all of their data. So you start off with a company, and a company like, say, Coca-Cola or some brewing company or whatever has multiple facilities, and those facilities can each have multiple buildings, and inside of each of those buildings is different systems, and like a boiler or a brewing thing, or just a variety of different systems. And then each of those systems can have multiple sensors attached to it. We also have an intermediate step called a sensor box, which is a thing that records or takes in all of the sensor data and aggregates it into a single piece of single chunk. But anyway, the point is we have these different sensors that are attached to these systems. And they can be sensors like temperature, conductivity, flow meters, so how much water is moving in or out. And for each of these sensors, we have recording of data, and they vary based on what the client wants. So sometimes it's seconds, sometimes it's minutes, sometimes it's 10 minutes, sometimes it's hours. So there's a wide variety in how frequent this data is collected. So the data structure that we came up with was really the foundation for the work that we did for the rest of the 24 hours. We built a system using open source tools. So we started with Ruby on Rails, and for me it was my first night doing Ruby, so that was exciting. I learned quite a bit. We also built in, so one of the nice things about Ruby was that it gave us the ability to have some strings just kind of for free. So like managing our data, so one of the big things that we had to do was write a tool to import the data, because we had a nice rich data set, but it was in CSV files, and so we had to come up with some way to import it and fit it into this data structure. So besides doing that, we also got for free the ability to manage this system. So we can go in and look at, say, a company, and we've got Beer Inc., and we could
awesome business, by the way.
Yeah. And so then we can go back and look at the facilities and see that Beer Inc. contains 3 facilities where they manufacture 3 different kinds of beers. And we could edit them, or so if we edit one, we can call it, instead of light beer, maybe we'll say like an ale, or bad beer, yeah, or part that we worked on for most of the time was the dashboard. And this, so the important part about this project was getting the data so that the people at these companies could understand where the water was coming in and where it was going and how their usage was changing over time. So, and they wanted to be able to compare their different facilities against each other. So maybe, why is that beer using so much more water than our dark beer? And of course, because it's watered down. But we can go through and select each of these different levels in the hierarchy. And you can see as he selects something, the next level down gets populated. So these are the different sensors that are available for these systems in those buildings, in those facilities for that company. And what we're looking at is, it looks like temperatures in 2 of the boilers, and now we're looking at gallons. So that must be like the amount of fluid that is inside of that container. And you can see the data is just coming in as we get it. We've got a nice little slider that you can select the date or the time range. As he moves the mouse across, we can see the actual values. Another handy thing about using Ruby is that it's all RESTful, so the ability to import new data it's practically effortless. So besides the big import that we had to do with the CSV, it's really simple to add new data as it comes in, and you would be able to watch that come in on the system.
Sort of a few other things to mention is, although it's kind of hard to tell, at this size, we're looking at a huge data set. I mean, if you know, a few of these, we got about 5 or 6 test files, and one of them contained like 40,000 separate data points. And just having the ability to plot those out, compare them against other different sensors, and to kind of look at that over time, and look at any specific point in time, and maybe you could see, you know, you're starting to rise when normally you would keep a solid level. And maybe there's some sort of outlier you could look into. Maybe there's some sort of leak in the system. So it was just really interesting to do that. Another thing that was really great, again, about using Ruby on Rails, is that we were able to add basically a service interface for free. So all of these AJAX calls we're making to fetch all this data can be hit by anybody. So they can fetch JSON versions of all the companies, all the facilities for those companies, all the way down to all the sensor data for any specific sensor.
Yeah, and click on that icon. You can see we can download the CSV data. We could get download that graphic as an image or a PDF document, print it. So this data is easy to put it in and take it out.
Put it in PowerPoint presentations, for instance.
Right. So I don't know that there's a whole lot more. We could keep adding sensors or just play around with it, but it works, and we were pretty happy to see all this data coming in and being visible and being able to compare the different sensors.
Finally, one other thing to mention is that the problem definition here and the solution that they were looking for wasn't really to develop out this whole system. This is really just kind of a preview of the sort of things we have the ability to do and the sort of things that they would have the ability to do. In reality, this was just sort of information gathering. So if you were to take this to a larger development team, the sort of things you can do with the current data you're getting in from your current systems.
Right.
And that's really what we're doing.
And it also kind of highlights some of the problems that will become apparent as this system gets developed more in terms of visualization and analysis and understanding the size of these data sets and the difficulty of really getting the big picture. For example, when you have multiple sensors that are of different types, so let's say you've got a temperature sensor and a flow meter sensor, one of them has a range of 0 to 100 degrees Celsius, the other has a range of 0 to tens of thousands of gallons. And so when you're trying to plot those on the same graph, I'm sure you can do like the 2 axes, but then you get a third sensor, and now you don't have enough axes. So there's going to be a challenge in being able to compare different kinds of data on the same graph, but being able to show it all in this timeline makes it a lot easier to understand what's going on in a system at any given time.
Anybody have any questions?
Is this an open API? I mean, do you have to take Watertech data, or can you input any?
Really, any any system that's kind of framed out like this with these separations and just the generic idea of a sensor, it was modeled after the data they gave us because it was a really great data set to have. But I do think that's a pretty solid representation of any kind of large-scale system that would look like this.
Right, and we even considered putting in a subsystem, so you'd have system and then subsystem and then sensor. But, I mean, you can pretty much take anything and kind of jam it into this hierarchy.
Especially because remember, this is very, very industrial data. And so like all the industrial data, there's going to be a lot of individual things that are going to have to be changed. So there's going to be individual data pipelines for every company that's going to need it. Because, you may not care about the temperature of a oil pipeline unless it hits some other kind of bound. Whereas I think there's something much more precise about doing beer. I don't know, I just drink beer, but I've heard from beer people that there's really important temperature range.
So what's your plan?
Yeah, what's your next step?
Well, I think one of our goals out of this was to give the Watertech guys an idea of what's kind of possible in 24 hours, what the data that they were trying to get will look like, and what they were, I guess what they were asking for, we were trying to show them what would look like. So the next step is really for them to have conversations with either us or other developers to flesh out the requirements a little more and spend some time actually developing a full-blown app.
So is the data open for anybody?
It's up to these guys, I guess.
As far as access to the data, I mean, because a lot of it's customer, we always have to get approval from the customers to share data, et cetera. So because it's their data, it's really not our data. And so realistically, the long-term vision is if the customers use this, then they will have access to their data set, but they won't have access to everybody else's. So we'll be somewhat confined to the actual